All right, let's look at this classic dynamic programming problem. We're given a list of currency bills. So given a list of currency bills, you're required to count the number of ways in which you can represent a certain amount, right? So we have a list. Let's call that bills, right? It's certain currency bill values. Let's just say it is $1, $2, and $5, right? So we're given a list of currency bills, and you're required to count the number of ways, all right, in which you can represent a certain amount. Let's say, let's call amount, and let's say we have $5, right? Now, let's just, let's just work through this solution very quickly because, this is just very small amounts of dollars and amount that we have considered, for example. So 5 can be represented as 5 ones, right? 1, 2, 3, 4, 5. That is $5. Or you can represent, chunk these two guys together. So that's like 2 and then 3 ones. That's $5. Or let's chunk these two guys together. So that's 2 twos and 1 1, right? That's $5. Or it is just the $5 alone, right? Which is $5. Now we got to be very careful. Since this is a counting problem, a case like a case like 1, 2, and 2 giving $5 is, even though correct, we'd be counting it twice, right? Because we already have the situation of 2 ones and 1 1. Just changing the order doesn't mean we're using new bills, right? So we got to make sure we don't count this guy as a separate case. Let's just keep that in mind. All right, let's clean up our workspace. Whoops. Let's, restore our good old 1s and 2s and all of them. All right, let's see. All right, sweet. Now we can go about this two ways, right? We could either have like a for loop, or we can do some kind of recursion, right? Let's stick with recursion. And let's start thinking about the problem, right? So what did we do? We had only $1 here, right? This was just $1 we were playing with. Then what did we do? We added the concept of a $2 bill, right? And then we are like, what happens when we include the $2 bill, right? These two scenarios happen. Or if we exclude the $2 bill, this scenario happens, right? Now, after this, we introduce a $5 bill, right? So when it's $1 alone, it's this case. When it's $2, it's these two cases. When it's $5, it's this case, right? Let's clean this up real quick. I'll explain in a bit why I said this the way I did. So roughly speaking, in our recursion, we need to look at cases of, counting when we include the new bill, or we have to count the case when we exclude the new bill. Now, if you remember from your permutation and combinatorics classes, or represents addition, right? So it'll be an addition of these two cases. For example, if I say A or B, you have to count the number of ways in which A happens and add it with the number of ways in which B happens, right? So it's not A and B, right? If it's A and B, it'll be multiplication, right? All right, so let's get that guy out of the way. Now we have some idea of what to do, right? Let's try, coding this out real quick. Basic recursion. We can go to dynamic programming once we fully understand the recursion case. So I already set this guy up, put our basic, function structure here. Let's see, let's just make sure this is correct. Whoops, let's see. Return 0. If this is all working correctly, we should see a print of 4 and then a print of 0. Let's make sure that it runs. All right, so our online compiler environment is good to go. All right, so we need to, roughly speaking, progress through every one of these bills, right? And then see if we include this bill, what happens, how many ways we get, and add it when we exclude that bill, right? Then we go and include this bill, right? We say what happens when we have 2 and $1 bill, or we don't count 2 and we say we only have the $1 bill, right? So we need some idea of going, like, traversing through this array, right? So we need a counter to keep track of that, right? So only because we need a counter to keep track of that, I'm gonna define a new function called countWays recur, right? Into this we'll pass our bills and amounts, and we need some index, right, to keep track of this. And we'll start at index 0, right? Now let's just define this function upstairs so we can actually go ahead and use it. Sweet. Right, define. So we're starting at index 0 and we're looking, oh, should I include the first index, second index, 0th index, remember? In Python, array start at 0, so 0th index, first index, second index, all those scenarios. Right, now since we, are making this recursion, right, we need to think of a base case, right? What happens when exactly should a recursion stop, right? Let's go back to the drawing board. So let's go back to the manual calculations, right, real quick. So we have $5, right? And we first went through how do we represent it using ones. How exactly did we as humans want the calculation to stop, right? We went ahead, we used one $1 bill, we had 4 remaining, right? That's remaining 4. Then we used another $1 bill. How much is that? That's 3 remaining. Then another $1 bill, 2. How much is that? 2 remaining. Another $1 bill, 1. How much is that? 1 remaining. Then when we use our last $1 bill, amount goes to 0, right? Remaining goes to 0. That's when we stop, right? So we can tell our computer to stop counting scenarios when our remaining amount goes to 0, right? So that's our recursion's base case. Since we are passing amounts to the recursive call, we would say when amount goes to 0, that's when we stop, right? When we code out the solution a little bit more, it'll become ever so slightly more clear, right? So if amount is equal to 0, we stop, right? And we say we have counted it as one way, right? Let's say, let's go through another quick example. Let's say we have 5, right? We use $2. The $2 bill, we're left with 3. We use remaining 3. We use the $2 bill, remaining 1. Right? Right? Remaining 1. And then we use the $1 bill again. So let's highlight this. 2, 2, 1, right? 2 plus 2, 4. 4 plus 1, 5, right? And then when we hit 0, right, we can say that's one way of representing 5, right? Which is 2, 2, and 1, right? That's one way. When did we stop this process? When we saw amount go to 0, right? That's exactly what we coded up here. All right. Now, we also got to make sure that the computer doesn't do something silly, right? Which is let's say we have 0 and we try subtracting another 1 from it, right? It goes into -1. Now, we really don't want to be in a scenario where we owe people money, right? That's not at all the idea of the problem. So when amount minus bill in consideration goes negative, right? That's not a valid counting case, right? We say that is 0 ways of returning the bill, because 0 ways of counting bills, because we really don't want to owe people money here. This is a not that kind of problem. All right. So if amount becomes negative, right, we need to return 0. Now let's think of some other scenario, right? What if our counter progresses, right? Our counter goes here, 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 and then tries to go beyond, right? In that scenario, counter's value would be more than the length of the bill's array, right? That would throw us an error because we only have 3 bills, and let's say we try to find what the dollar amount of the 4th bill is. We got to make sure to exclude that case, right? So when index goes past, meaning becomes more than the length of the bills, right, we still return 0. So we can see that these two if statements are, both returning 0, so we can chunk these two guys together, right? And since this is Python, not Java, we can just say and we're done. Gotta love Python. All right. Now we gotta, from our example above, right? We gotta encode 2 things, right? Which is counting the case when we include the new bill, right? What happens? And when we exclude the new bill, what happens, right? Let's start with exclude the bill, right? So let's say exclude the new bill, right? We would still call this function, right? We would pass the bills array. Now, since we're excluding that bill, our amount remains unchanged, right? We're not subtracting anything from it. But what are we doing? We're going to the next bill. We're like, screw the $2 bill. Let's go directly to the $5 bill, right? So since we're going to the next bill, right, we're gonna say skip the current index, go to the next one, and don't subtract that amount. Don't subtract that from amount, right? Now, this will be or include the bill, right? Let's see. So count ways, recur. Oh, whoops. It's a bad spelling. Right, count ways, we pass in our array. Now, since we're counting the bill, let's also say the bill in question is bills at position index, right? That makes sense? Because that is the bill in question, right? That is why we came up with the notation of index, right? Is to track what bill we're talking about. So we will take amount and subtract that from bill, right? So bills at index, or why don't we just use the variable since we have it, right? Amount minus bill, and we keep that index, right? Because we're including the case of that bill, so we will still keep this index, right? In this scenario, when we are not including the bill, we don't subtract it from the amount and progress to the next bill. So I hope that is clear. If not, rewatch this section again, and if you still have questions, leave me a comment, right? Okay, now we gotta add these scenarios, right? Remember the OR, the all-important OR. So we remember from programming classes, from permutation combinatorics, that OR is a plus, right? So let's take advantage of that. Or a plus, right? And then you just return this stuff. Right, so this should work. Let's see. This is super basic recursion, right? We'll look into good old fancy dynamic programming very soon. Let's see. Okay, error. Let's see what went wrong. Line number 8. So in our case, recursion is not stopping. Let's try to figure out why our recursion is not stopping, right? Let's see. Let's see. Amount goes to 0, right? In which case we return 1. That makes sense. If amount is less than 0, oh, we are not we're not saying when amount is less than 0 or index. Before we had amount less than 0 and index is less than greater than length of bills. In that case we return 0, right? If we make this to an OR, this should stop correctly and should not exceed the maximum depth of recursion. Let's see. Okay, we still have some problems. What is it? Oh, bill is not defined. Let's go ahead and define it real quick. So bill is equal to amount. Oh, I'm gonna run out of battery real quick. Amount at, oh, not amount, is bills at index. Sweet. Let's run this guy. All right. So that ran successfully without syntax errors. That's good. Now let's make sure to return this value, right? And run it again. Sweet. We get 4. All right, now let's look at dynamic programming.